Welcome to the online lecture series on 8051 microcontroller. In this video lecture, we shall see to generate a square waveform using the timer but using the interrupt method. Okay, so in the syllabus, it is mentioned to write the program in C. Okay, so the question is as follows. You should read the question very carefully. Okay, write a 8051 C program. Uh, if so, using interrupts. Okay. So if they ask you to write the program in interrupts, you should write the program using the interrupts only. Okay. So write an 8051C program using interrupts that generates a square wave of 200 microsecond. So the time period is given on P2.5. Okay. He has asked to use timer 0 to create the square wave. Okay. So you are free to use either mode 1 or mode 0. It depends upon you. Okay. If you are able to generate 100 microsecond in mode 2, then it is better you go to mode 2, because as I have said earlier, mode 2 is more accurate. Okay. Uh, then assume crystal frequency of 11.0592 megahertz. Okay. So let's see the program. So from the crystal frequency, we got the value of one count 1.085 microsecond. Now we should calculate the value to be loaded in TH0 register. Okay. Now the total time period is 200 microsecond. Remember the square wave, I said it has got 50% duty cycle. So you should consider the delay of 100 microsecond. Okay, 100 microsecond it will be on and 100 microsecond it will be off. So the value of n will be equal to 100 microsecond divided by 1.085 microsecond. So which comes out to be 92. So the value to be loaded in TH0 will be equal to 256 minus 92. It is 164. In hexadecimal it is A4H. Okay. Now we have to write the program in C using the interrupt method. Okay. So let's write the program. Hash include register 52.h. Fine. So we have to generate the waveform on P2.5, right? So it is on P2.5. So we will define that. So S bit square wave, we will give the name square wave is equal to P 2.5. So point we should initialize like this. So the square wave will be generated on P 2.5. Fine. Then void main, open and close the brace. Okay. First thing is make port 2 as output port. Okay. P2 as output port. Okay. Then we are using timer 0, right? So timer 0 we are using in mode 2, right? Yeah, so we have subtracted from 256 means, so timer 0 is used in mode 2 configuration. Okay, so that's why T mod will be equal to 0 into 02, correct? Okay, you can refer to the T mod. Okay, so timer 0 in mode 2. Fine. Then what else? You have to load the value in TH0. So TH0 is 0 into what was the value? A4H. Okay, A4H. Okay, so this is for 100 microsecond. Then we have loaded the value. Now since we have to generate using the interrupt, so we will enable all the interrupts. Okay, enable all interrupts. Then now I'm generating interrupt using timer 0, so that interrupt should be enabled. So ET0 is equal to 1. So enable timer 0 interrupt. Correct? Fine. So we have enabled the interrupts. Now we have to start the timer. Okay, for that TR0 is equal to 1. Start the timer. Okay, now remember how we had programmed in the polling method. So after starting the timer, we used to wait for this TF0 flag, right? Like while one. Okay, but here we don't wait because we will write the program in interrupt. So in the forever loop, okay, the processor can do any other work. So I don't have any other work in this program, so I will simply write any other work processor can do in this while. Okay, so because we have enabled the interrupt, we have initialized the timer. So when the interrupt comes, it will go to the ISR. So I need to write the interrupt ISR now for the timer. So void. So since I'm using timer 0, so timer 0 void, then the keyword interrupt. And what is the interrupt number for timer 0? Let us see that. I have forgotten. So the interrupt number is 1. Okay, so it is 1. So you should remember this interrupt number. Okay, now what should happen now in whenever the interrupt comes? So that this interrupt comes every 100 microsecond. Okay, so first you will make it high, wait for 100 microsecond, then you have to make it low, then again wait for 100 microsecond. Okay, then again you have to make it high. So in the sense, for every 100 microsecond we are complementing that bit. Okay, so in C program we can do that using this tilde operator. Okay, so what it will do is, suppose if this bit was initially 0. Okay, assume P2.5 was 0. Okay, then when we start the timer, so after the 100 microsecond has elapsed, so it will come to the interrupt. So P2.5 was 0, so negation of 0, it will become 1 now. So it will make it 1 and it will come out of the loop. After that again 100 microsecond will elapse, again it will come. So now it was 1, it will make 0. So in this way it will complement. Now one thing you might have noticed here, when we used to write the program using the polling method, okay, for example we used to write like this, right? Y TF0 is equal to 0. Okay, we used to wait. Afterwards we used to clear the TF0 flag. But here we are not doing that. Why? Because when we write the program in the interrupt method, the hardware automatically clears this TF0 flag. And this is true for all the interrupts, whether the timer interrupt or the external interrupts. So the hardware automatically clears except for the serial interrupt. Okay, so thereby the time required for clearing this interrupt is saved. Okay, and your program is more accurate. Okay, so this way we generate the square wave using the interrupt method. Okay, thank you.